Okay, example 2, using slopes to compare unit rates. Example 2, using slopes to compare unit rates.
Proportional relationships and thinking about lines and slopes, really a lot of these concepts are related. And in fact, looking at these kind of related concepts, especially thinking about lines, even equations of lines, allow us to actually understand our own world better and will shower us with a variety of interesting possibilities. In fact, that reminds me of a really interesting example that involves, of course, a shower. Let's check it out together. Mr. Bird is deciding between two different shower heads. The equation y equals 1.75x represents the rate in gallons per minute that shower head A uses water. So that means that the water is kind of coming out at a speed of 1.75 gallons per minute. Now, I'm going to show you a graph that actually represents the rate that shower head B uses water. And our challenge is to figure out which shower head uses water at a slower rate. See, today a lot of people actually want to conserve water, and so they want to actually buy shower heads that use water at a slower rate. So this is actually kind of interest. So we've got two shower heads that Mr. Bird is considering, and let's actually take a look at them. So we have shower head A. Maybe that looks like this. So there's shower head A, and what we know about it is that the amount of water used is given by the equation y equals 1.75x. Now, let's just use all the knowledge we've already established to actually say a bunch of stuff about this equation. First of all, since it can be written like this, we know automatically that, in fact, this is representing a proportional relationship. It's also representing the graph of a straight line that passes through the origin. And in fact, we know what that constant of proportionality is, which we now think of also as slope, the same idea. It's just that constant number in front of the x. So 1.75 is that rate. 1.75 is the slope of this line. Now, we can actually verify that for ourselves if you want to. I'll just talk you through it. But we can just look at this equation. When you have y equals a constant times x, that constant is always the slope or always the constant proportionality. But just for fun, let's just see that we could actually do this for ourselves by taking a look at a little table that I made in advance. This is a table where I actually use this equation to figure out for different times how many gallons this shower head would use. The first one's actually really easy, right? If in 1 minute I see that I've used 1.75 gallons, and that's easy to see. Let x equal 1. When I plug in 1, 1 times 1.75 is equal to y, which represents the gallons, and so I see 1.75. If you plug in 2, that's asking for what's 2 times 1.75, which if you think about it, it's pretty easy to see. It's 3.5, and so on. Now, what we could do if you want to would be to look at the ratio of these numbers. So you could look at, for example, 1.75 to 1. You could look at 3.5 to 2. You could look at 5.25 to 3, and even 7 to 4. And if you simplify all those, what you're going to get, in fact, if you write as decimal, is 1.75. So in fact, we actually see that we have a constant ratio. We have indeed proportionality where the constant proportionality is 1.75, but we knew that just by looking at the equation. So in fact, all of this wasn't really necessary, but I wanted to remind you of how we could actually figure it all out if we had to. In any case, I don't care about any of this stuff, so it's gone. All I care about is that we know that the rate here is equal to the slope, which is equal to 1.75. Okay, now that's for A. Now we've got to take a look at B. And maybe B looks like this. Let's see, B maybe looks a little different. Maybe B looks like this. Woo! Look at that shower head. Well, now that you've seen both shower heads, which one are we going to pick? Let's stay tuned and find out. Because what we have to do now, you see, is we have to look at the information we have for shower head B. And all we have for the information of shower head B, of course, is its graph. So here's the graph. That's all we're given. We're not given an equation. And now let me just actually remind you that, in fact, these axes actually have particular values here. This here represents the time in minutes. And for that time, this value tells us the amount of water used. So this is amount of water, and that's represented in gallons. And that's all we're given. And so now we're supposed to make some sense of this. Well, let's actually compute the slope of this line. Well, to compute the slope of this line, we need 2 points, and then we look at the change in y over the change in x, or rise over run. So one point I'm going to pick is just the origin. That's a really easy point. Whenever you can pick the origin, pick it. So 0, 0. And now I need a second point. So let's take a look at this point right here. Now, what's that point right there? If I come straight down, you see it's at that little notch there. And what value is each notch? This is 10. So let's see. 2, 4, 6, 8, 10. So they each have value 2 units. So this is 2, 4. So this value right here is 4. Maybe I'll just write that in right here. 4. And what's the corresponding value? If you go way up, you see it's right here at this hash mark. What's that? That's 2, 4, 6. So it looks like it's 6. And so that's going to be a 6. So you know how to find the slope. The slope is the change in y over the change in x. So that's 6 minus 0. So the rate, which is also the slope, is equal to 6 minus 0, which is 6, divided by 4 minus 0, which is 4. So it's 6 over 4, and that simplifies to 3 halves, which is equal to 1.5. So which value is smaller? Which rate is smaller? Because the smaller the rate, the slower the rate. Well, one slope we saw was 1.75. The other one is 1.5. And certainly we know that 1.5 is less than 1.75. And so that actually shows us that this is the smaller rate. So this is the smaller rate, which means that the water comes out of B slower. So it's slower here. Which means if we want to pick the shower head that uses the least amount of water of these two options, we're going to go with B. So the answer is, which shower head uses water at a slower rate? The answer is B. And if you want a slower rate water shower, then Mr. Bird, in fact, is going to pick B. So there are lots of different ways of expressing a proportional relationship. We can look at the equation, which actually is a simple example of an equation of a straight line, and we can actually find that constant proportionality by looking at the number that's multiplying the x, or we could actually look at a graph of a straight line that passes through the origin, and if we figure out the slope of that line, then in fact we're equipped again with that constant of proportionality. Either way, whether we look at it visually or look at it with algebra, we can actually see proportional objects and proportional relationships. Have fun showering yourself with proportionality. I'm actually going to wash up right now, and of course, I never go anywhere when I wash up without my rubber ducky. I'll see you soon.
All right, now after viewing the video, to do example 2 should be a little bit easier to understand from the textbook. The equation y is equal to 2.75 times x represents the rate in barrels per hour that oil is pumped from well A. The graph represents the rate that oil is pumped from well B. Which well pumped oil at a faster rate? Which well pumped oil at a faster rate? The equation or the graph? Step 1. Use the equation y equals 2.75 times x to make a table for well A's pumping rate in barrels per hour. All right, so what we're going to do is time is going to be in hours, and that's going to be our X variable. So for hours, we're going to say 1, 2, 3, 4 hours. And then we're going to use these values to figure out the corresponding Y values. Now, we can test it out real easy because it said that the equation is Y is equal to 2.75 times X. All right, so if we put a value of 1 in, that means after 1 hour, we're going to have 2.75 times 1. And that's going to be 2.75. When we put X in it being 2 hours, now we got 2.75 times 2. That's going to be 5.5. For 3, we got Y is equal to 2.75 times 3. That's going to be 8.25. And then for 4, we're going to have 2.75 times 4. And that's going to give us an answer of 11. Notice how the Y value cannot be determined until we know what the X value is. So in other words, the Y value is the output value and it's dependent upon whatever the X value is. Now, for those of you who still may be somewhat confused, all we're doing is we're writing the equation down. This is what you should do. Y is equal to 2.75 times X. When X is 1, we replace X with 1. So now 2.75 times 1 is 2.75. When X is 2, we replace X with 2. So now we got 2.75 times 2, which is going to be 5.5. And we do the same thing with 3 and 4. So once again, X is your input, that's what you're putting in, and Y is your output. All right, now that we made the table, now we're going to use the table to find the slope of the graph of well A. Slope is equal to the unit rate, and we've already know how to do this based on the previous sections. So we know we got to say 5.5 minus 2.75. 5.5 minus 2.75 over, remember that's our Y value, over the X value, which is 2 minus 1. 2 minus 1. So we end up with 2.75 divided by 1. And if we did that for 8.25 minus 5.5, over 3 minus 2, and 11 minus 8.25 over 4 minus 3, we would still come out with 2.75. All right then, so for A, for well A, we know there's 2.75 barrels per hour. Now step 3, use the graph to find the slope of graph of well B. Use the graph to find the slope of the graph of well B. Slope is equal to the unit rate, which is the rise over the run. In this case, it's going to be 10 over 4, which is 2.5. Now let's show you how we got that 2.5 or the 10 over 4. All right, so all we do is we go along our graph, we go along our line, and we're trying to find a point where it's perfect on a crosshair, like right there. It's perfect on a crosshair. All right, so in other words, where two lines intersect, like right here, like so. All right, so that point right there, can you see that? Right there. So my X value is 4, because I'm counting by 2, 2, 4, and my Y value is 10. So to find the slope we said is the rise over the run. So that's going to be the rise was 10. So that's going to be 10 over 4. All right, so that's how that was determined. All right, so now that we have 10 divided by 4, and 10 divided by 4 is 2.5, we're going to compare the unit rates. And it turns out that 2.75 is greater than 2.5. So Wells A's rate, 2.75 barrels per hour, is faster. 2.75 is greater than 2.5.